At 1419 UTC on October 27, 2025, 2119, in Bangkok, the window closed and left a residue. A steep, coherent lift, a brief rising chirp, and a measured pivot shared across two channels. It looks like intent, or the shadow of it. Three hypotheses enter: a rare natural fluctuation, a hostile-looking maneuver, or an artifact born inside our own machinery. The opening claim is modest. Evidence first, names later. If the second path is real, someone or something touched the band exactly where our sensitivity is highest. If the first nature staged a scene that imitates purpose with unsettling precision, if the third, the ghost lives in cabling, clocks, or code, and every alert since last quarter must be reread. Error cuts both ways. A false alarm breeds fatigue and spectacle. A false calm teaches blindness when vigilance is owed. Facts and methods will lead. Time-locked traces, sliding window cross-correlation, coherent spectra, and a full audit of oscillators and buffers will be stacked before any label is allowed to stand. We will test each signature against libraries of storms, meteors, and licensed modulations, and we will keep the word attack behind glass until the evidence can carry it. For now, the only proper question is simple and hard: signal or story? 3, I divided by Atlas, is a listening web, not a single eye. Distributed stations layer radio, microwave, and near-infrared channels over local context, weather, ionosphere, ground vibration. Every frame is stamped in coordinated universal time and reconciled to an atomic standard, so a ripple in one valley can be compared to a ripple an ocean away. The pipeline ingests, aligns, and preserves raw buffers around any trigger. Time is the common currency that lets weak coincidences become testable claims. The first discipline is cleaning without forgetting. Raw streams shed mains, hum, flicker, and known carriers via calibrated notches. Baselines are rebuilt nightly from quiet windows using robust z-scores and median absolute deviation, so an outburst cannot tilt the floor that judges it. Where spectra are crowded, masking tables remove licensed beacons before metrics are computed. What survives this pruning is the remainder that might be novel or merely better noise, and it is carried forward with error bars, not confidence. Observability has edges. Terrain casts radio shadows. Cities add spectral haze. Moisture bends higher bands off course. Instruments drift with heat, cables age, and digitizers saturate under fast spikes. The network tracks these with quality flags: clock health, cable loss, front-end headroom, temperature. Claims that rest on flagged minutes are quarantined by default. Independent stations use different vendors and firmware lines so that a local gremlin cannot counterfeit consensus across the mesh. Hostile pattern is a technical phrase here, not a verdict. It means a repeatable geometry in time, frequency, space that appears aimed, a directed phase change, a step sweep through our most sensitive bins, or a chirp whose slope recurs with lags consistent with physics rather than buffering. Such a pattern must cohere across separated stations within tolerances implied by baseline length and elevation. Purpose, in this context, is what remains after tools designed to erase intent fail to do so. Detection is a bargain with error. Lower thresholds catch more truth and more lies. Raise them and the quiet wolf walks past. Receiver operating curves choose working points, but redundancy is the real defense. When radio records a chirp, infrared should register heat, or at least a physically sensible silence. When neither agrees, the claim parks until corroboration arrives. Time alignment uses discipline oscillators locked to satellite time. cross-correlation, coherent spectra, and phase unwrapping run before any label is allowed. Only then do we ask the essential question, given these limits and flags, what did the network truly have the power to see last night? At 14:19 UTC on October 27, 2025, 2119 in Bangkok, a clean discontinuity surfaced on channel alpha. The floor climbed by nearly 2 robust deviations in under half a second and settled onto a narrow shelf. 20 seconds later, a brief rising chirp crossed the same band. Phase unwrapping showed a small, coherent pivot, more like a deliberate bearing change than drift. Channel beta followed with a lag just under 1 second and a slightly weaker rise. That offset is too long for shared cabling and too short for most tropospheric quirks. So the team treated it as propagation, not plumbing. Channel gamma remained quiet, which complicates the claim, but is consistent with its beam pattern, leaving a low elevation gap at that hour. Absence here is caution, not acquittal. Against a month of quiet sky, amplitude lived between the 95th and 99th percentile for roughly 6 minutes. The cadence that emerged, rise, hold, micro dip, chirp, decay, repeated 3 times with intervals contracting by nearly fixed fraction rather than a fixed second count. Nature can stutter, controllers step. The distinction will live or die on coherence, lag, and whether independent sensors agree on order. Facts and methods. Reconstruction proceeds in layers. First, lock all traces to the discipline oscillator and audit every clock against the satellite spine. Second, compute sliding window cross-correlation and magnitude squared coherence between alpha and beta so that short alignments are not averaged away. Third, interrogate maintenance ledgers and license spectrum maps for any tone or sweep that could mimic the chirp. Fourth, examine raw buffers for clipping or quantization scars at the analog front end. Each pass either keeps or erodes the geometry. The question tree splits 3 ways. Natural. What physical process yields a directional pivot without broad spectral Bloom sporadic E, grazing meteor trails, or high altitude discharges, and can any of them explain the contracting intervals? Artificial. What purpose fits a step sweep through our most sensitive bins, followed by silence, probing dynamic range, training a null, or rehearsing a small denial? Artifact. Where could the pipeline invent the same order and lag across independent hardware shared timing, firmware regressions, or a thermal episode that both stations would confess? Objectives are conservative and ranked. 1. Extinguish artifact, exhausting drift, loose connectors, firmware rollbacks, and front-end headroom tests. 2. Bind lag to geometry, comparing measured offsets with expectations from the station baseline under free space assumptions and low elevation paths. 3. Discriminate cadence, matching against catalogs of licensed modulations, industrial sweepers, and known natural signatures. Uniqueness is not proof, but misfit narrows options. 4. Model intent, running step frequency and chirp controllers through the network sensitivity map to see whether a modest source could reproduce slope, ratios, and stall. Michio Kaku's assignment is precise and public-facing. Translate method without sacrificing doubt. Dates, durations, lags, and error bars will precede any charged term. The narration will use hostile-looking pattern inside a frame of competing hypotheses, not as a verdict. Success criteria are equally plain. We seek recurrent order across at least 2 independent channels, a lag bounded tightly enough to favor distance over buffering, coherence that peaks in the same narrow band on each cadence, and a cadence misfit with natural catalogs after corrections. Failing that, We seek the ordinary culprit that collapses the mystery with relief and receipts. Either outcome advances the record. The purpose of Part 4 is to stack anomalies honestly until only a smaller set of stories survives. Reconstruction starts at T-minus 15. Alpha rides a flat, well-behaved floor with the slow respiration of a quiet ionosphere. Beta mirrors the calm, offset by the small bias our nightly baselines remove. Gamma skims a humid horizon. Its beam geometry at this hour typically trims the top of its band. Nothing telegraphs drama. A dull prelude is the best starting point for claims that must survive daylight. At T-minus 2, alpha shows a hairline lift too small for ordinary z-scores to notice, barely large enough for robust metrics to flag and release. Beta stays inert. Gamma offers the usual low elevation hiss. Operators note no interventions, clocks agree, temperatures hold. The quiver is logged as a curiosity that may either crystallize under scrutiny or dissolve when context returns. T0 arrives with clean edges. Alpha's envelope tilts up by almost 2 robust deviations in under half a second and then settles onto a narrow shelf. Phase unwrap reveals a measured pivot, like a compass needle committing to a new address. Beta answers just shy of a second later with a similar, slightly smaller rise. Gamma remains unmoved. The system promotes the event to Tier 1 and pins the raw buffers to immutable storage. From T+2 to T+6, the geometry becomes articulate. Alpha's phase continues its unhurried turn. Beta acquires a shallow tremor atop the rise, a signature consistent with a weaker or off-axis path. Sliding window cross correlation produces a traveling peak that shadows the turn without snapping into perfect overlap, enough to suggest distance rather than buffering. Buffer audits find no artificial delay. The lag behaves like space, not software. At T+7, a short, rising chirp cuts through alpha's passband, stepping neatly through bins where our sensitivity is highest. Beta records a thinner cousin with a marginally steeper slope. Gamma stays uncommitted. Licensed carriers are notched. Maintenance tones cataloged. Neither explains the path. The chirp sits just beyond any sanctioned test and carries the posture of intent or an uncannily accurate imitation. Between T+9 and T+15, cadence appears. Rise, hold, microdip, chirp, decay. Intervals contract by a near constant fraction rather than a fixed count. Natural systems can compress cadence when geometry evolves or energy drains. Engineered controllers often tighten steps by design. The difference will live in coherence, order, and whether separated sensors retell the same story with a lawful lag. T+15 to T+18 brings the blink of saturation in one alpha bin, followed by swift recovery. Engineers replay raw buffers, checking headroom and transfer curves. Down-quantizing the capture preserves shape, arguing against simple clipping. Artifact is not dismissed, only starved. Every cable, clock, and front end is pressed for an alibi. At T+19, the pivot pauses. Alpha steadies as if having reached an aim point, then drifts back a fraction. Beta echoes with a thinner plateau after the same lag. The stall is brief yet diagnostic. Directional behavior claimed conservatively with independent sensors and a lag that fits baseline geometry better than any plausible buffering sketch. From T+22 to T+25, the third cadence closes. Once normalized, its intervals match the first two within tolerances unlikely under this noise level. Coherence peaks reappear in the same narrow band. Alpha and beta maintain a phase relationship inconsistent with independent randoms. Gamma's silence remains a guardrail. It weakens easy certainty, but fits the known low elevation gap in its beam at this hour. After t plus 30, the edifice decays. Floors on alpha and beta sit slightly elevated for roughly 5 minutes, then relax. The faint afterglow could be processing inertia, thermal settling, or the authentic tail of a cooling source. The pipeline marks the period quiet with memory. Here, silence is not void. It is residual structure without the bright spine. Anomaly stack, morphology. The event is a composite, shelf, tremor, chirp, pivot, appearing in the same order on two stations with a consistent lag. A single oddity begs coincidence. 4 in sequence demand modeling. The stack is a ledger, not a verdict, but it acquires weight with every repeated component. Sensor independence. Alpha and beta run dissimilar front ends, separate cables, distinct digitizers, and divergent firmware branches. Both locks reference the same satellite spine but discipline locally. Loopbacks cannot forge the cadence. Only Alpha received a firmware patch last quarter. The mirrored timing on Beta argues against the single station ghost. Artifact remains possible but increasingly taxed. Time frequency structure. The chirp slope traces a narrow diagonal that matches neither logged licensed modulations nor common industrial sweepers for the region and hour. Natural catalogs are not empty competitors. Sprites, meteors, and scintillation each have signatures. The contracting intervals and tidy repetition strain those fits more than they trouble engineered controller models. Geospatial context. Baseline geometry between alpha and beta predicts sub-second lags for low elevation sources along a particular azimuth band. The measured offset favors that family over a high zenith origin. Gamma's beam at the time leaves a hole along the same corridor, removing an objection rather than proving a path. Operational context. Maintenance ledgers list no contemporaneous beacons. Nearby facilities report activity, but not at these times, and their emissions occupy notched ranges. Weather is docile. Solar indices are uneventful. The background grows methodically boring, which is the desired soil for testing extraordinary claims. Rejection tests, natural. Meteor libraries are searched for grazing trails capable of narrow, rising sweeps. Some resemble the chirp, but lack the shelf tremor preface and the repeating contraction. Ionospheric structure can pivot phase while smearing amplitude more broadly than observed. High-altitude discharges have radial fingerprints, yet their timing statistics resist the measured interval tightening. Rejection tests artificial. Step frequency and chirp controllers can reproduce the diagonal. Simulations, driven through the network sensitivity map, show that a modest transmitter aligned along the low elevation corridor can match the slope, alpha, beta strength ratio, and brief stall. Models are scaffolds, not proof, but they make the physics walkable. Rejection tests, artifact. Clock drift is exercised in replay. The event lag refuses to follow. Injected overload scars waveforms in ways the capture does not share. Firmware rollbacks on alpha do not summon historical cousins. The artifact ledger thins, yet keeps a page open for unknown interactions between temperature, gain staging, and synchronization. Figures and telemetry. A spectrogram panel shows 3 cadences with contracting intervals and a recurring chirp slope. A polar plot of angle-like behavior captures the brief pivot stall before decay. Cross-correlation matrices peak along a curve consistent with station spacing and low elevation. A 3-way confusion chart tallies traits that support or resist the natural, artificial, and artifact branches. Facts and methods. Robust baselines are recomputed nightly. Outliers are judged by both p-values and Bayes factors where priors can be stated. Coherence is measured in overlapping narrow windows to avoid transient smearing. Multiple comparisons, penalties accompany any catalog search. Every geometric inference is cross-checked against buffer paths and resynchronization routines. What survives the stacking is a disciplined discomfort. Two sensors agree on order, slope, and a lag that behaves like distance. A third stays silent for reasons the geometry can defend. The cadence is tidy where nature is usually messy. The chirp walks our favorite bins with unsettling efficiency. And yet the system has erred before without malice, with heat and habit. Doubt remains the hinge. As the sequence closes, the team drafts the bill. Part 6 will reckon posterior weights for each branch and the price of being wrong in either direction. But before the arithmetic, Part 5's lesson stands. Even the tail's quiet carries meaning. The next window will decide whether this stack is a rehearsal, an uncommon natural theater, or a ghost we taught our tools to see. The bright minutes end and the array exhales. Alpha and beta settle onto floors a shade higher than before, then drift down over roughly 5 minutes, no fourth cadence, no straight chirp, just a hush that remembers being loud. In this system, silence is not empty. It is a boundary drawn by what failed to appear. No lightning maps aligned, no license beacon stirred, no maintenance tone confessed. The negative ledger narrows the field of stories the positive minutes could tell. If the signature was natural, the quiet fits a transient. A meteor trail cooling, a patch of ionosphere relaxing, a high-altitude discharge ending its theater. Transients leave tails that fade without choreography. If it was artificial, silence reads as discipline. A probe stepping through our most sensitive bins and then cutting power to avoid overexposure. If it was artifact, the hush is the pipeline, cooling buffers, clearing, oscillators settling, a machine returning to baseline. Each branch can borrow the same quiet and claim it as proof. The task is to score the fit, not the rhetoric. Facts and methods. The afterglow is treated as a data set. We estimate dwell how long the elevated floor persists, then compare it against archives of known transients and known resets using survival analysis. The hazard rate remains roughly constant, arguing against a mechanical countdown and for a memory that decays without a metronome. Coherence between alpha and beta drops to baseline almost immediately, hinting that whatever bound the channels during the bright minutes was cut quickly rather than bled away. Silence buys room for cross-checks that noise would drown. Environmental logs are rescanned in the hush. Seismic taps, power harmonics, operator chat, thermal drift, nothing lines up. Dead zone maps are overlaid on the following window to hunt recurrence under similar geometry. None appears. Absence across a second window is not proof, but it fences out models that rely on periodic rehearsal. The modest conclusion is threefold. 1, the system forgets fast, and the forgetting is smooth. 2, the tail carries no clocked beat that would betray a scripted shutdown. 3, the quiet does not name a culprit. It strips away easy villains and easy victories. What remains is the cost of declaring early. Part 6 weighs those costs in probabilities, how much false alarm we can afford, and how much missed rehearsal we cannot before the next window asks the data to choose again. The record is now thick enough to weigh. 3 branches remain: a natural transient that mimics aim, an artificial act that touches our most sensitive bins, or an artifact grown inside our own pipeline. The goal is not drama, but calibrated probability. We keep signatures that survive audits of clocks, cables, and code. We discard those that evaporate when methods change. What endures earns weight. What fails becomes instruction. The artifact branch was tested first and hardest. Clocks were pinned to the satellite spine and nudged on replay. The measured lag refused to follow. Front ends were driven into synthetic overload. the captured waveform did not share the scars. Firmware history split months ago. Rolling back alpha's last patch did not summon cousins in archival noise. Shared buffering was mapped and time tagged. No path could counterfeit the observed order on two independent chains. Artifact does not vanish, but it shrinks to a narrow outline. Nature keeps credible ground. Meteor trails can write short rising sweeps. Ionospheric structure can pivot phase without help. Electrical discharges at altitude can leave shells that breathe like living things. Yet the tidy repetition, the contracting intervals, and the chirp walking exactly through favored bins force natural catalogs to bend more than they like. Several candidates rhyme, none keep the meter. Natural remains possible, especially given the quiet tail, but it is no longer the default. The artificial branch gains shape without gaining certainty. Simulations routed through the network sensitivity map show that a modest transmitter along the low elevation corridor could reproduce the slope, the alpha to beta strength ratio, and the brief pivot stall. A controller that tightens step timing on each pass explains the fractional contractions. Cutting power after the third cadence explains the immediate collapse of coherence in the tail. Two cautions remain: gamma's silence and the lack of an external platform to echo the story. Plausible does not yet mean proven. Priors matter. The network begins from mundane assumptions and updates with evidence. After updating, the artifact path moves to unlikely, the natural path settles at low to moderate, and the artificial path rises to moderate with broad uncertainty bars. This is a sketch, not a seal. A new data set can redraw it in an afternoon. Science marks its steps in pencil until replication inks the line. Now the bill. A false positive is expensive in trust. Naming a hostile pattern without adequate support pulls cameras, drives policy, and trains operators to chase phantoms. Attention is a finite resource. Spend it foolishly, and the next real event competes with fatigue. A false negative is costlier in risk. If a rehearsal just mapped our sensitivities and we filed it under weather, we teach ourselves to ignore intent. The next rehearsal may not be gentle. The invoice arrives late and large. Risk management lives in design, not in rhetoric. First, tighten time. Add a second discipline oscillator at each station and hardware time tags, driving lag bounds down to a small slice of a second, so distance and buffering can part ways. Second, diversify modes. Pair radio and microwave with compact optical and low frame infrared at primaries, letting a spectral shout search for heat, shadow, or a physically sensible silence. Third, deepen buffers. Preserve more raw seconds before and after triggers. Raw truth is the refuge when models disagree. Fourth, codify triggers. A preliminary flag requires two independent channels in ordered agreement, plus a clean context check against licensed spectrum and maintenance ledgers. An escalated alert adds a third corroboration, either a partner station or another sensing mode. Fifth, red team the array. Commission internal step sweeps and quiet withdrawals, then measure which patterns slip through. Systems that have rehearsed with themselves do not panic when the room goes loud. Communication needs rules as strict as detection. Public narration begins with dates, durations, lags, and confidence, then offers names only if evidence can carry them. The word attack is not an adjective. It is a verdict earned by survival through dull explanations. Until that bar is met, the precise phrase is hostile-looking pattern, held inside a frame of competing hypotheses and explicit uncertainty. Provisional resolution, then, artifact unlikely, natural possible, artificial plausible, with large uncertainty. Recommendation: hold the claim at watch, widen coverage along the low elevation corridor, solicit time, stamped raw buffers from neighboring arrays for the same window, and prepare a replication checklist that fixes thresholds and analysis order before the next pass. If alignment returns with the same cadence and geometry, posterior weight will move with conviction. If it does not, the episode will fade into the archive, where unresolved patterns sometimes return years later to complete their context. What remains is discipline. The task ahead is not to crown a story, but to narrow it. Part 7 sets the clock, names the test that can break the tie, and defines what success looks like. A tighter lag, a third eye in the corridor, and a cross-mode glimpse that either finds heat where the chirp once walked or finds a principled nothing. The cost of patience is time. The reward is a claim that stands in daylight. The next observing window opens at 1500 UTC on October 29, 2025, 2200 in Bangkok, and lasts a little over an hour as the low elevation corridor returns. Alpha and beta will stand with deeper raw buffers and a shadow oscillator at each site to cross-check the satellite clock. A compact optical and a low-frame infrared unit now sit at alpha, so a spectral chirp can be tested for heat, shadow, or a principled nothing. Gamma's beam is retrimmed to erase last time's gap. The plan favors decisive tests over clever theories. Lag comes first, dual clocks and hardware time tags should bound arrival offsets to a slim fraction of a second, enough to separate distance from buffering. Order comes next, shelf, tremor, chirp. Pivot must recur in sequence across stations, or the claim returns to storage. Cross mode then asks whether radio shout has thermal or optical consequence, or a silence that physics can defend. Geometry finally adds a third station in the corridor, so phase and lag can triangulate a band of origin rather than a rumor. The trigger doctrine is posted above the consoles. A preliminary flag requires 2 independent channels in ordered agreement, plus a clean context check against licensed spectrum and maintenance ledgers. An escalated alert demands external corroboration or a second sensing mode. Raw timestamp buffers, not post-process comforts, will be shared with neighboring arrays for the same window, so another team can rebuild our path line by line and argue with our methods if they must. Risk tolerance is written into the workflow. Thresholds are fixed before the window to restrain opportunistic tuning. If a cadence appears, analysts will pre-register the comparison set, natural catalogs, industrial sweepers, and controller simulations, so that success is judged against a declared yardstick. If nothing appears, the null is not a failure. It is a bound-on recurrence that narrows the priors the next night. Michio Kaku's closing note is modest by design. Civilizations do not announce themselves with cannon fire. They arrive first as margins that refuse to balance. Nature can draw clean lines when we stare long enough, and instruments can sketch ghosts when we trust them too much. The work is to love neither outcome. We are calibrating a sense for intent in a universe that mostly does not intend. If the cadence returns with the same order, lag, and slope, now seen by a third eye or a second mode, posterior weight will move with conviction. If it does not, the bright minutes and the quiet tail will join the archive, where unresolved patterns sometimes wait years to complete their context. The hinge is set. We step through with doubt intact and tools sharpened, letting the data choose the story.